No one wants to be suspended. But almost 50 years ago, that word made a universe of difference in opening a new window on the cosmos. I'm Dave Doodling, Education Director at the New Mexico Museum of Space History. 45 years ago this month, NASA launched an astronomy success story that happened because of one word. In the 1960s, NASA's Marshall Space Flight Center, which had led work on the Saturn V moon rocket, knew that science missions were becoming more important. Marshall's Dr. Ernst Stuhlinger, who helped install the cosmic ray detector on America's first satellite, formed a team that came up with an ambitious design for 3 high-energy astronomy observatories to study the invisible universe. We humans can only see a narrow part of the electromagnetic spectrum, which our eyes and brain render as red, green, and blue. Most of low-energy infrared and radio, and all of high-energy ultraviolet, X, and gamma radiation are blocked by the atmosphere. It's as if we can only hear middle B, C, and D on the keyboard and are deaf to the incredible symphony that the universe plays. We didn't even know the universe is aglow in higher energies until balloons and then rockets carried science instruments above the atmosphere. On June 12, 1962, White Sands Missile Range launched a small instrument to study solar X-rays reflected by the moon. By accident, one of the lead scientists, Dr. Riccardo Giacconi, discovered Scorpius X1, the first X-ray source detected outside our solar system. Discoveries by small satellites led to big questions and plans for 12-ton boxcar-sized observatories requiring a massive Titan IIIC rocket for launch. 2 satellites would rotate end over end so they could scan the entire universe. A third would carry 2 telescopes for detailed views. It was an immense project. Too immense, it turned out, for new budget realities that were hitting the federal government in the early 1970s. On January 2, 1973, after years of painful groundwork and with the Viking Mars lander project running over budget, NASA headquarters told the HEO team to halt. Immediately, Astronomy Director Jesse Mitchell and Program Manager Dick Halpern lobbied to change their orders from canceled to suspended. This gave them time to downsize the program. The first step, of course, was to make the spacecraft smaller. Size and weight equal money. Working with TRW, the spacecraft builder, NASA devised a new approach that used existing designs that could fly on the less expensive Atlas Centaur. Then they went through the painful process of dropping instruments and science teams. What emerged was a set of 3 affordable satellites, weighing only a third as much as the original designs. The basic approach was the same. HEO 1 and 3 would scan the skies for X-rays, gamma rays, and cosmic particles. HEO 2 would carry a single X-ray telescope based on a design about to launch on Skylab. Plan B was accepted, and the HEO program moved forward. On August 12, 1977, HEO 1 was orbited. Its large area sky survey instrument was developed with assistance from New Mexico State University. A year later, HEO 2, soon renamed the Einstein Observatory, carried the largest X-ray astronomy telescope yet orbited. A few hours before liftoff, Giacconi, who later won the Nobel Prize in Physics for his pioneering work, crawled inside the rocket's nose cone to remove the telescope's dust covers. Finally, in 1979, HEO 3 carried a special detector to look for gamma rays from antimatter and a chamber to measure cosmic rays. While designed to last just 6 months, the observatories averaged more than triple that. HEO 2 lasted almost 2.5 years. The trio made astronomers rethink much of what they thought they knew about how the universe is built. Discoveries included hundreds of new sources, many matching optical sources, X-ray jets from Centaurus A and M87 that aligned with radio jets, the Crab Nebula winking off and on in time with its optical counterpart, radioactive aluminum from supernovas near the center of our galaxy, and indications that cosmic rays, high-speed fragments of atoms, come from shock waves rather than inside supernovas themselves. We saw more than enough to support development of dozens more X-ray and gamma-ray observatories, including the powerful Chandra X-ray Observatory with a telescope as big as the one planned for the original HEO-B spacecraft. Not bad for someone who got suspended from work. Thanks for watching, and stay tuned for more space history stories.